Hello and welcome to today's class. In today's class, we discuss rationalization of binomial surds. So basically, we say that binomial surds are surds that are made up of more than one term. All right. An example of a binomial surd would look something like, let's say, you have the surd of x plus the surd of y. So basically, whenever you have a surd that is made up of more than one term, then we say that that is a surd. All right. So the surd of x plus the surd of y also usually has what we call a conjugate surd. All right. It usually has what we call a conjugate. Conjugate. Let me make sure that I have that right. A conjugate surd. All right, so a conjugate surd is basically the same surd, except that if this is a positive, then it's going to be a negative. So the conjugate of surd of x plus b will be surd of x. Now instead of having plus, we'll have minus surd of y. So that is what the conjugate of our surd here in Roman 1 would look like. All right. So now, why am I talking to you or introducing to you the term conjugate surd? All right. So usually, when you multiply a surd by its conjugate, you end up rationalizing it. All right. Remember, all surds are irrational. All right. All surds are irrational. So whenever you multiply a surd by its conjugate, you end up irrationalizing it. So basically, what I'm trying to say is, if I was to take the surd of x plus the surd of y, okay, and I were to multiply it by its conjugate, and that is the surd of x minus, now instead of plus I have minus the surd of y, then whatever I'll have this and will be a rational number. And so the process of converting a surd to a rational number is what we call rationalization. All right, is what we call rationalization. So this class basically is going to be about how to rationalize surds. All right, how to rationalize surds. So what happens when you're given a problem and you're told to rationalize a surd? And in this particular case, because in the other video we looked at how to rationalize monomial surds, we'll be looking at how to rationalize binomial surds. Let us handle our first example and move on to the next one. Okay, awesome. So here comes our first problem. We've been given 7 all over the surd of 2 plus the surd of 3, and we have been instructed to rationalize this particular surd. All right, so remember, for us to rationalize a surd, we are always going to mainly focus on the denominator. All right, so when you're told to rationalize a surd, in this particular case, any surd that and it's a fraction, always think of the denominator. So it's the same as dividing a surd. All right, so whenever you're told to rationalize a surd and it's in a fraction form, always think of the denominator. So our aim here is to make sure that this denominator is a rational number. All right, so what are we going to do? Remember what we said about rational numbers, okay? About multiplying surds, with their conjugates. Remember what we said about multiplying surds with their conjugate. When you multiply a surd by its conjugate, you end up getting a rational number. So for us to rationalize this particular surd, we're basically going to multiply the numerator and the denominator by the conjugate of the denominator. All right, so the conjugate of the denominator in this particular case will be, I'm going to have this in bracket, will be the surd of 2. Now, instead of having plus, we're going to have minus, the surd of 2 minus the surd of 3 right there. Okay, so that's going to be the conjugate in this particular case. All right, so we're going to also multiply the numerator by the same. So in the numerator, we're going to have the surd of 2 minus the surd of 3 as well. So I want you to note that by multiplying this surd by this here, the conjugate, we are not really changing its value, because you see, if we divide this by this, we just want to get 1. It's the same as multiplying this surd by 1. Okay, except that in this particular case, we're choosing that one be its conjugate all over its conjugate. All right. All right. So, anyways, you get it. So let us first look at the numerator. Okay, let us first look at the numerator. All right. So in the numerator, we are going to have 7 multiplying our conjugate side here, and that's going to be 7 into the side of 2 minus the side of 3. Awesome. So I don't see a need for us multiplying or expanding this bracket. We can just leave it at that. I mean, there is no need, all right? So the side of 7 multiplied by whatever we have by the conjugate will just be 7 into the conjugate, all right? So that's it with the numerator. So concerning the denominator, now that's where some magic will happen. So let's look at the denominator. So we are going to try and denominator. We're going to try and multiply this side, that is the side of 2 plus the side of 3 by its conjugate, which is root 2 minus root 3. And I want you to note that we are going to get a rational number. Okay, so we are going to expand the same way we've been expanding before in our previous classes when we were looking at algebraic expressions. So we're going to have root of 2, the side of 2, multiplying the side of 2 minus the side of 3, okay, plus the side of 3 multiplying the side of 2 minus the side of 3, like that. All right, so then I want you to note that root 2 times root 2 will basically give us 2. Root 2 times root 2 will basically give us 2. So let me write that 2 here. Will give us 2. All right, so then root 2 times negative root 3 will give us negative root 2 root 3, okay, which is the same as root 6 basically. Yeah. All right, then of course this here will give us root 3 multiplying root 2 will give us positive root 2, okay, root 3, okay, then root of 3 multiplied by negative root of 3 will give us negative 3. Awesome, awesome, awesome. So note that these middle terms made of surds, that is negative root 2 root 3 plus positive plus root 2 root 3 here, will basically give us 0. Okay, then we'll be left with 2 minus 3, 2 minus 3, and of course that will be 1. Okay, 2 minus 3, and that will be 1. All right, so when we bring both the denominator and the numerator, the numerator and the denominator together now, all right, so we are going to have 7 into the side of 2 minus the side of 3 all over our denominator is equal to 1. So this is just the same as 7 root 2 minus root 3. And that there is going to be our final answer. All right, so that's it for that particular example. So why don't we handle the last example? So we've actually rationalized our denominator, and in the process of doing so, we've solved this particular problem. All right, why don't we handle the last example, then call it a day? Awesome. For our last example, we've been told to rationalize side of 2 minus side of 3 all over 3 root 2 minus 2 root 3. So basically, when we told to rationalize and it's in a fraction form, it basically means that we have to make sure that our denominator is a rational number. And how do we do that? We do that by multiplying it, that is the denominator and the numerator, by the conjugate of the denominator. So the conjugate of this particular problem here is going to be very simple. We're basically going to take the whole term as it is, except that instead of having negative here, we're going to have plus. So by doing that, we'll have gotten the conjugate. All right, by doing that, we'll have gotten the conjugate. So that's going to be 3 root 2. Instead of minus, we're going to have plus, and that is where the change basically is 2 root 3. Okay, and so whatever we multiply by the denominator, we shall also multiply with the numerator. So the same, we'll have 3 root 2 plus 2 root 3. So the reason why we do that is so that we do not change the value of our surd. You see, when we divide these two, we're just going to get 1. So it's basically the same as multiplying the whole surd by 1, except that one is written in such a way that it's a conjugate of this denominator that we are seeing down there. So starting us off with the numerator, okay, starting us off with the numerator, we are going to have root 2 minus root 3, okay, multiplying our conjugate, that's going to be 3 root 2 plus 2 root 3 there, of course. So that's going to be, okay, we're going to expand it the same way we expand any brackets that we have, any algebraic factorized bracket that we have anywhere. So that's going to be root 2, surd of 2 into 3 root of 2. Oh, sorry, plus 2 root 3. Okay, so we are maintaining this and breaking this. Minus root 3 into 3 root 2 plus 2 root 3. Awesome. Yes, so basically it's going to be root 2 times 3 root 2. Okay, so root 2 times root 2 give us 2. So we'll have 3 times 2 there. So we're going to have 3 multiplying 2 when we multiply root 2 by the first term. Okay, plus, okay, root 2 times 2 root 3 will give us 2 root 2 root 3. Okay, 2 root 3 there. Okay, so and then right here we're going to have minus, okay, minus negative root 3 times 3 root 2. Okay, that's going to be negative 3 root 2 root 3. Okay, negative 3 root 2 root 3 there. And so lastly, we're going to have negative root 3 times 2 root 3. Of course, root 3 times root 3 there is going to give us 3. Okay, but it's going to be a negative, so it's going to be 3 times 2. Okay, so it's going to be 2 times 3 there. Awesome. So I want you to look at whatever we have here. These are common surds. This is root 2, root 2, root 3, root 3. Okay, so basically it means that it's going to be the same as taking 2 minus 3. Okay, 2 minus 3, and of course that will give us negative root 2 root 3. Okay, 2 minus 3 will give us negative root 2 root 3 there, and of course 3 times 3 will give us 6. Okay, and of course that will give us 6, and of this one here, in this particular case, negative 2 times 3 will also give us 6. Okay, negative 6, sorry. So basically we are going to have a situation where we have 6 minus negative 6 minus 2 root 3 minus 6. So 6 minus 6 basically will give us 0, so that we're going to be left with negative root 2 root 3 in the numerator. Okay, that is for the numerator. And now on to the denominator. Okay, let me have some space right here. So denominator. Onto our denominator, we're going to multiply this here by the conjugate. Okay, because this is our first class, we're going to do it step by step. Otherwise, this is something you can just calculate by looking. All right. So basically, we're going to have 3 root 2 minus 2 root 3 into 3 root 2 plus 2 root 3 there. Okay, so we expand and maintain 1. We expand it, so we're going to break 1 and maintain 1. So basically that's going to be 3 root 2 into 3 root 2 plus 2 root 3 there, minus 2 root 3 into 3 root 2 plus 2 root 3. So we've actually broken this bracket and maintained the other one. All right, so when we multiply 3 root 2, okay, 3 root 2 by 3 root 2, we are going to have 3 times 3 giving us 9 times 2, root 2 times root 2 will give us 2. So basically, that is what we are going to have there. We are going to have 3 times 3 giving us 9 and root 2 times 2 giving us 2 there. And then, of course, we're going to have 3 times 2, of course, plus 3 times 2 giving us 6, and root 2 times root 3 will give us root 2 root 3. Awesome. All right, now for the second bracket, we're going to have negative 2 times negative 3 giving us negative 6, and of course root 2 times root 3 will give us root 2 root 3 right there. And of course, then you notice that we're going to have negative 2 times 2, that will give us negative 4, and of course root 3 times root 3 there will give us 3. So it's going to be 4 times 3, as you can see. Now I want you to look at these numbers in the middle here. That is 6 root 2 root 3 minus 6 root 2 root 3 is the same as having 6 minus 6, okay? So that one there will give us 0, yeah? That one there will give us 0. So we'll be left with 9 times 2, which will be 18, okay? And minus 4 times 3, okay? You see the negative sign here, that's why we're having minus. Minus 4 times 3, of course, that is going to be 12. And so when you do that math, that is 18 minus 12, you are going to get 6. Now, for our final answer, we're basically going to have, for our final answer, we're going to combine our numerator and the denominator. So we're going to have them both. And of course, our numerator was negative root 2, okay? Negative root 2 root 3 there, all over, of course, our denominator, which is 6. And so we can leave our answer at negative root 2 root 3 all over 6 as our final answer. So that's it for this particular class. If you have any questions, don't shy from texting it in the comment section. I'll get back to you as soon as I can. All right, adios and have a good day.